this. So let me share the screen. So yesterday we stopped here, and so this is where we stopped yesterday. We designed a circuit like this, where we used it to control. We controlled 5 LEDs using a 9-volt battery and a diode and a resistor, a 10K resistor, and IN4148 PN junction diode. So like what we did yesterday, we tried to like make sure the current that flows from this battery is being allowed to move in only one direction through the PN junction diode, and the voltage is being limited by this 10K resistor, so that the high voltage will not affect the LEDs. So today we are going to be looking at simulating some of these diagrams, and like I told you, we are going to create a little complex circuit diagram. So before opening a new one, so let me try to explain where we can simulate. So simulations on Eagle is made simple and easy to do. As you can see from this graph, there is this, which is simulate. If I click on this, to ask that I haven't mapped anything, so that I need to map it. So no problem. So it's going to display something else. So before you can do simulations, there is one thing you need to understand, which is you need to map all the circuits with the incoming inputs, with the inputs that are needed before them. Like what is said here, unmapped modules found. All components must be mapped to an intrinsic model or SPICE subcycles prior to simulation. Before simulating, be sure to map your components from the add module dialog. So we need to map our components. We need to use mapping for them. So how do we do that? So let's try to create a new file. Okay, so now this is a new design or a new workspace. Like I told you, before you start, one important thing you need to do is you save it. You save your design. So let's save it as my thought design. So we have saved it as my thought design. So the next thing is to add a part, which is usually the frame. So you click on add part, then you type frame here. So we do use frame A size. That's the frame we do use. So then you add the frame, your workspace. Then you click on it, you escape, then you cancel it. So now, as you can see, the title, it has formatted the title as my thought design, which is the name of of what we are doing, or the name of this folder, document number, dates not saved. At the end of the day, it's going to save it for us. So so the next thing is understanding simulations. So what do we mean by simulations? Simulation is just uh, a process of understanding what's happening on this on the circuits or in the circuits, so that before building a physical device, we know that, okay, yeah, this is it and this is how it works. Meaning, simulation will allow you to like understand or to get the output needed to get what to let you understand what is happening in the circuits before you build a physical device. So one of the advantages of simulation is going to reduce time for building or for deployment, and also is going to reduce the costs of damage as well. So if you go directly to the physical development, you might make a mistake, so which will cost you another thing, or to get other components like that to do so. But with simulations, you don't have to do that, because everything that will be happening, the input voltage, the output voltage will be showed be shown on the simulation or on the waveform as well. So that is what simulation is. So let's get started. So with these simulations, we have to add some part to our designs. So we go to add parts, as we used to do. Then you search for NSpice. So before doing this, let me show you one thing. When it comes to spicing, if you know, when I know ground node is, no, I don't want to do this. That's not what I mean. So NSpice, I wanted to bring something like NSpice. Okay. So okay, let's try to get this as well. So this is a configuration for simulations, although after the design of the circuit we are going to use, I'm going to show you again. So this is the configuration for the simulations. The source, that will be the voltage source. We don't need the start value, we don't need the end value for this, because we are using a voltage, not a variable or a voltage regulator. AC sweep, yeah, you can leave this as deck. So start frequency, you might want to remove the start frequency, but start transient is very important. So of all these simulation type, we need this transient time is very important. Start transient, you can leave this as 20 milliseconds for the start. For the stop, want it to be like 20.02 milliseconds. So points, we might want to change the point to 1000. So these are the configurations we do. 1000. So for the maximum point, you can leave it as 2000. For temperature, you might leave it to room temperature of 25 degrees Celsius. So for the DC simulation options, you don't need to do anything here. Just leave it that way. For the transit simulator options, this as well, you don't need to do anything. You can leave it that way as well. So then you click on update netlist. Okay, what is our netlist? You know, in to simulate anything, to simulate any circuit on Eagle, we need the spicing. We need spice. Spice is very important in simulating on Eagle. So the next thing is output. We don't have any output because we haven't started simulating, so we don't need that. We can't get any output for the plot as well, which is the waveform. We can't get anything here as well because we are not we have not connected anything to the simulations. So resets. Okay, no, sorry. This one is to 1000. So let's update what you're doing. So we can update it now because we haven't connected anything to it. So that's just about the configurations. The transient time is very important for us. And the start time, the stop time, and the point as well, 1000, maximum point 2000 temperature, room temperature. So I've had it, maybe I've designed my circuits. I can just click on simulate and it will start simulating for us. And because there's no ground node, so we can't simulate anything here. Okay, cancel. Cancel this. So another important thing is this is simulation result toggle, although we might not be working on this. But another important thing is voltage probe. That is where we are going to use a probe. Like, for example, if you are working with a multimeter, you have a probe, the positive and the negative. So for simulations, we need to add the voltage probe rates to any of the outputs or anywhere we want to simulate the voltage inputs or the voltage outputs. So you might want to add a voltage probe or these nodes now. So for the phase probe, yeah, that means if you want to get you want to get what is currently happening, or the phase, the waveform, all the stuff like that. So what we don't need that for now. We need to start with our design. Then during the simulations, we can do that. So now let's move to the next one, which is to add some parts from the spice part. Yeah. So type spice here. Oh, spice simulation, as you can see here, ng spice simulation, spice contact and compatible library part. Because when we tap on the simulation, it says we need to get some of our node, especially the ground node. This is the ground node, simulation ground node. We need to get it from as part of our parts before we do anything. But one other thing is we don't have another important thing is there's supposed to be other components under this ng spice simulation. But there is none here. So we'll be making use of the ground and see what we can do with it. So now let's create a circuit using a transistor. Let's say 2 transistors. Then we have different resistors and connect them to a capacitor and other stuff like that. So now, what this circuit will be doing is we'll be using this circuit to amplify the signal, meaning we are going to get an output, and then use the transistor to amplify the input voltage, then give it to the output to any loads that already needs it. So now you go to parts, we need a transistor. Yeah, then we type transistors. We have different types of there's different type of transistors at home. So this is general purpose transistors. Can you see how it looks like? But we don't want to use this kind of transistor. We want to use a transistor that's complementary. These are power transistors. This is a power transistor. So these are the power transistors, and we need to hide it. So we are not making use of power transistor here. We are making use of N-type transistor, meaning some kinds of simple transistors. So hello, can you hear me? Okay. So there is PNP transistor that I told you initially. There is PNP, there is NPN transistors. These are the two types of transistors you're having, the PNP and the NPN transistors. So this is an NPN transistor. So let's add an NPN transistor. For an NPN transistor, you find that that's the emitter here, which is the one having this arrow, is negative, while the base is positive, while the collector, which is the output, is negative as well. So that's why it is named NPN transistors, or that's why they are named NPN transistors. So the other one, which is a PNP transistor, the arrow here will be coming in. That's another difference between them. The arrow here will be coming in. So whenever you say transistor, whose arrow is coming in from whose emitter part shows that the arrow is coming inside, it means it's a PNP transistor. So for a PNP transistor, the emitter will be positive, the base will be negative, and the collector will be positive. So that's why they are called PNP transistors. So for the NPN, you will see that the emitter side, the arrow will be facing down. So whenever you say a transistor which arrow is facing down like this, you should know it's a NPN transistor. So let's add an NPN transistor. Let's use these kinds of transistor. So let's add this transistor. We double click. So let's add it to our workspace. 1, 2. So we are using only 2 transistors here. So another thing we need is resistor. We need resistors for this our work. So we know we do use during the course of this tutorial, we've been using US based transistor. So let's continue to use it. 411 V transistor. So we need something like 4 resistors with these. Yeah, we need 4 resistors with these. So we need one at the collector side. We need one for the 2 collector side, which is the output of the transistors. We need one at the base side to bias the base. So the meaning of biasing the base is connecting a resistor to the base of the transistor. And the essence of this is to get the transistors ready that, oh, there will be an income, or there is an income of of there will be an income voltage, or there will be an input voltage on just to get it ready for the voltage. So that's resistance of the transistor. So so let's escape these. Okay. So we need something very important as well, which is a voltage source. We normally we supposed to make use of NSpice voltage, but it's not showing here. I think it do shows in my other Eagle, while I'm using Eagle 9.6 here. So, but the other Eagle, ngSpice, which is this library for simulations, has a lot of components as well. So now let's search, let's say for voltage. So we want to make use of a voltage source, mini battery. So let's search for battery because you can't find any. Well, I was just saying voltage regulators here. Yeah, let's make use of a voltage regulator as well. So that I want you to know what a voltage regulator is. And I would like to show you in this, I would like to show you guys in the simulations as well. So this is how a voltage regulator looks like. A voltage regulator is a kind of regulator or voltage regulator that tries or that regulates or reduces or limits the voltage, the incoming voltage to its own value. Let's say if the incoming voltage, meaning if the input of this regulator is 28 volts, and this regulator is a 12 volt regulator, it's going to limit that input 12 voltage to an output of input 28 voltage to its own output, which is 12 volts. So that's what a voltage regulator does. So the same thing, let's add a battery. So we're adding a battery. Let's make use of the special battery we do use. So we're making use of this battery. So this is a battery we are using. Escape. So then we need a capacitor. We need capacitor as well. Capacitor. So we've not been using capacitor here. Yeah, so that's nice. We have NSpice capacitor here. ngSpice, which is the one that is best for simulations. So let's add this. So this is Spice module. The Spice module capacitor that is best for simulation. So let's see if I can get transistor, ngSpice transistor here. Let me check here. ngSpice. Okay. So let's add another capacitor so that we make use of it. We add those capacitors to the to the um to the emitter part of the transistor. So now these are the components that we're making use of here. And one important thing is to connect the simulation probe as the simulation node, which is the simulation's ground node to the circuit. So let's go to part and add the simulation ground node. Spice. So here is the simulation ground node. Oh, sorry. Let me add it again. So this is simulation ground node that we'll be making use of. So we need two, or you might need more than that. So the next thing is to make our connection to rearrange our design and make the necessary connections. So can you see from this side, you see where the components we are making use of, where they are located. And whenever you are making these kinds of designs, it is better for you, or one of the rules is to make sure that your designs are like in the middle. So being in the middle will be the best way for us to do it. So you add all of these components to the middle. So we now come back here again and look for move. So this is move. You tap on this, then you tap on any of these components, and when you tap on it, so instantly it's a oh sorry. So the same thing for the next for another one. You tap on this as well. Tap on this. So we have this voltage regulator here. There's this resistor here. So now let's start our connection. So the first thing is a battery, which is a source, which is a power source. So this is a power source. So we want it to be vertical instead of being horizontal like this. So to make it vertical, you come here, you click on rotate here, then you tap on it, rotate. So we want the voltage, the positive side of the battery, which is this longer line, and this short one is negative part of the battery. So we want the negative side to face the ground, to face here, and the positive to face here as well. So you tap on it again and tap on. So yeah, we are done with the battery. So the next thing is to connect the battery to some of these things that we making use of. So sorry, I haven't changed it from so let me change it to move. So this is move. Then the next thing is to connect some of these to other components to the battery. So we have the voltage regulator. The voltage regulator will be the outputs. Then we have all the store side. So the next thing is we want to connect this battery to this resistor, and this resistor will be connected to limit the current that will be coming out from this battery. So you come here, click on next, you click on next, then the junction of this will then be moved. So we've connected the battery to this. Then we want to connect the resistor. The resistor is a non-polarized component. It doesn't have positive, it doesn't have negative terminal as well. So the next thing is you can use any of these two terminals of a resistor or two sides of a resistor, like this side or this side. So you can use any of these sides to connect to any of those components. So now I want to connect this with the voltage regulator. So that's nice. We've done that. So the next thing is we want to connect. Oh, sorry. So the next thing is we want to move the other components like this resistor that will be used to bias. So this is another resistor. So once connect this resistor to this, then the other side of this resistor, we want to connect it to, okay, let's add another resistor to serve as a base bias. So let's add another resistor, two more resistor that will serve as bias resistor. So we want to add two more resistor to escape. So then let's move this. So we may want to rotate this resistor. So this has been rotated. Oh, sorry. So let's move this resistor. Then connect the resistor with this. This is net. So then want to connect this resistor to serve as a bias resistor to the transistor, to this transistor. So the next thing is we want to connect this other part. We want to connect another resistor. So we want to use want to connect the outputs of this transistor, which is this side, the collector, to the input of this resistor, which is the the base. So the next thing is it connects here, and we connect it this way. So with this, we've connected the outputs of these, the output of this to the input of this. So then you will want to connect another resistor here. So this becomes a junction. Then we want to connect it to this. So another thing is this capacitor. We come to move. We move this. We move this. We connect this side. We connect this with this. So the capacitor we are making use of here is a non-polarized capacitor. This might be a mica capacitor or a ceramic capacitor. So we connect this here. So let's move this. So let's delete this and make sure the so I'm gonna move this. So we now connect this capacitor here with this. Then we connect these resistors as well. Move this resistor. So once we want to connect this resistor to the ground to reduce the voltage that will be coming to the transistor, because the current enters through the transistor through the negative side, which is the emitter. So we might not need one resistor again, so making it just only one resistor. So the next thing is to connect these together to the ground. So how do we do that? We come here, we come here, we come here. So the transistors have been connected, but not connected to the negative side of the battery. So that's the next thing we are going to do. So let's move. Oh, we might not need this resistor again. Connect the probes together. We want to connect to the negative side. We want to connect the ground to the battery, which is the simulating ground to the battery, and this as well to the battery. So we can now connect these using the net here. This is connected to this, and to connect this, there are two ways of doing this. Either you do it this way. Let's say, let me move this to this side. Either we do it this way and connect it here. Yes, we've merged. So we are merging this due to the fact that this has the same elements with the other one. This and this have the same elements, are the same components. So if I connect these to another component and I connect this to another component, a warning like this will show that, am I trying to merge this and this together? So he said yes. We merge it, definitely this and these are the same. It's like you make a connection between them. Okay, let me do this. So this is one part, or these are a way to do it. So there is another way to do it. Let me try to show you that as well. Let me delete this as well. Then move here, move it here as well. So the next thing is to connect them directly. Bring the battery here, connect it here, and then add the probe. Let me move this. I can add the probe here, or take it here and add it. Perfect. So I can do it this way, and I can do it in the other way by removing these long wires, by removing these green wires, and just connect this to the probe and connect this side to the probe as well. So these are the way I can do that. So we are done with the simple circuits, a little complex circuits. So then let's do it this way. Let's delete this. So anytime you want to delete, just come here, click on delete, and tap on anything you want to delete. I'm going to delete one. So the next thing is is to name all these components here, the battery, the resistors. Oh yeah, we've not connected. Yeah, a voltage regulator has three terminals: the inputs, the outputs, and the ground. Here's the input, here's the output, and here's the ground. So we need to connect the ground to this overall ground as well. So we need to do that. Connect this ground to the overall ground as well. So we had this is the ground. Okay, sorry. So we come to part again. Type on spice, search for spice. Sorry for that. SPICE simulation, double tap on this, add this, escape it, and cancel it. So we are done with adding. So the next thing is to connect this and this together. So we have matched this and this. So this, for example, if you want to check whether this ground and this ground are connected together, so you come to name, click on this. This is 0, right? New name 0, right? Oh, sorry. Here as well. Oh, sorry. Come to name, click on this 0 as well. So meaning this label and this label are the same, 0 and 0. We've matched them together. So I can change this one to ground, GND. So can you see this is GND? Then I'll come here as well, rename it. If you don't rename it, they are not going to match together. GND as well. Okay, connect 0 and GND. So GND. So the next one is we need to add values to the batteries. So here you come to value, you tap on the battery. What value do you want to give? Let's say 28 volts, or let's say 12 volts, 12-volt battery. Okay, so this, okay, no, we need to add the units of a battery, which is a voltage. Okay, so this is a 12 volts battery, and so the same 12 volts we come here. Then let's give a name. Let's give a value to this voltage regulator. What's the value? Let's say we are having we're gonna make use of a 6 volts voltage regulator. 6 volts voltage regulator. So meaning this voltage regulator is a 6 volts, voltage regulator. And physically, if you want to know a 6 volts voltage regulator, whenever you get a voltage regulator, just look, you see it this way, 7806. Anytime you see a voltage regulator and you see in part of it, like an indicator where, or I should say a nameplate like that, if you see something like a 7806, 7805, 78 means positive, and 06 means 6 volts. If you find it as 5, it means 5 volts voltage regulator. If it is 12, we see that it is 12 volts voltage regulator. So that's how to know the value of a voltage regulator. So we've added this voltage regulator to be a 6 voltage one. So the next thing is we want to label some of the parts, or we are not done with the values. What's the value of this resistor? Let's give it a 1K resistor. 1K. What's the value of this resistor? Let's give it a 10K resistor. What's the value of this resistor? Let's give it a 1K resistor. Although everything has calculations. And this, let's give it something like a 1.5 resistor. We tap on the resistor, 1.5K. 1.5 kilo ohms resistor. So we have labeled our resistors. We have not labeled the capacitor. Let's give this a 10 picofarad. Let's name this a 10P as well, 10 picofarad resistor, capacitor. So save it. One of these transistor, we don't need to, part T1 has no user definable value. Do you want to change it anyway? So we don't need to change the value because the transistor has no user definable value. They have static values like that. They have a predefined values of No resistance like that. So now the next thing is to label some of the parts we'll be simulating. So let's label this side as V input. This is voltage input. Let's name it as V in. Okay. This is voltage input. Uh, this side too as V in. Okay. Well, so this is the voltage input. This is we might want to. Okay. Let's another important part to name is the output of this of the first transistor, which serve as input of the second transistor. Tap on this. Let's put it as VQ, VQ, VQ. So this is the output. This is the output of what you are doing, which is serve as the output for any load or any other circuits we are switching or we are amplifying. So let's name these as V out. So here we've labeled the voltage, and let's label this as VA. I just put it as VA to look like the output of a voltage regulator. So so after labeling, the next thing is to add a voltage probe to it or to them. So let's add a voltage probe to them. Here, our voltage probe is V in because you have labeled it. It's going to do it by itself, V in. So now if you add a voltage probe here as well, it's going to bring it out for you. We have, let's say we have voltage of VA. That is the voltage here. Let's add another probe here, which is the VQ. We want to add a voltage probe here, VQ. Adding a voltage probe is very important for simulations so that we will be able to get the value for V. And let's add a voltage probe here, which is a V out. Then you save it. Hope you are following the steps. The first time you design your circuits using the SPICE components, then you make sure you had the SPICE ground node, which is this. It's very important for simulations. Then you label, you add values, you rename. If you need to do that, you rename the component you are using. And you add values, which is very important. The values will determine the outputs from this will be the input side of the resistor, and this is the output side of the resistor. So any resistor you add, the value of the resistor will have an effect on these of the outputs of this voltage. Because the resistor limits the flow of current, is going to limit the current. While this voltage regulator changes or regulates the 12 volts that enters here to a 6 volts, because it's a 6 volts voltage regulator is going to reduce the 12 volts that enters in into the input and make sure it's 6 volts that comes from this circuit. So we want to check, we want to get the voltage that comes out of this voltage regulator. That's why we're adding a probe here. And so here, we want to know the voltage that enters as the input for this transistor. We want to check the voltage, the overall output voltage. So you save these. Then the next thing is to simulate these. So how do we do the simulations? Like I told you, come here, you click on simulate. Map models one on the map and spice of simulate. Okay. is very important. So add model. So we have map. Okay. So there's one thing we need to do. So we are getting this error. Unmapped models found. All components must be mapped and physics. Okay. If we had model. I got it. For the simulations, it's only I was able to verify only one part for the spice simulations. So which means it is this ground, only this ground it is mapping. Um, so let's update the parts. So this resistor, this one. So we are mapping each. Let's see whether it's going to. We are mapping all these modules together. We map these resistors one by one. So let's try to map them. Let's try to add them to the module. So you check each resistor, you map it, because that's the error that simulations is bringing. We need to map them. So how do you map them? You tap on the components, you come to add module, you map it. Yes, okay. Yes, map done. We come here as well. Let's add this module as well. Oh, verify the spice types map. Okay. Oh, yeah. We can't. Okay. I'm coming. So let's leave this one for now. Let's map others. Map, add module. The map. Okay. Yes. Okay. Done. For the battery as well, this is not the battery for simulations. So we won't be able to map it. We've not been able to map the battery. We've not been able to map the voltage regulator, meaning we need to change this battery. We need to change this voltage regulator. So let's try to map these resistors. If you see done, meaning it has been able to map it. Okay, yes, done. So this transistor, let's check as well. So this transistor, we can be able to use it. It's unable to map it. If before we can be able to load this model, we need to add a name. And so this transistor as well, these two transistors, we won't be able to use it for simulations. Anytime you see done and it is marked, definitely we can be able to do so. So 1, 2, okay, let's map this capacitor as well. So this has been verified and mapped. This has been, so okay, let's map this resistor as well. So these active components, uh, this transistor and voltage regulator and battery, we can be able to map them because they are, we need to load the module. I don't have the module on my system here. So let's click on OK. So, so, um, so in spite of this, we go to part again and find a SPICE transistor that we can be able to map. Transistor, okay. So let's search for transistor itself. We can get NG SPICE transistor. We have this. Yeah, that's nice. This is the one we use for simulations. Yeah, NG SPICE. We use NPN. So let's add this transistor. We are gonna delete this. So gonna remove this. Let's delete this. Delete, delete. So let's move this. Let's delete the new connection. So move this as well. So the next thing is to reconnect these stubs. If we can't get this voltage regulator for simulations, we find another way to do that. So let's move this as well. This capacitor has to go down, this has to move, and this has to move as well. So connect these to the capacitor, connect these here, and we got to move these. We got to increase this, increase this, increase this, increase this, increase this, increase this as well. Move these as well. Move this resistor to make it straight. Then find a way to connect this. Let's delete this. Let's delete this. So let's connect this and this. Delete this as well. So let's connect them back again. This is being connected. So let's move this. Not this, I mean this. Yeah, so Control S again. So the next thing is to find for the battery source ngSpice for the battery source so that we can be able to simulate it. So these are the number of if we can get ngSpice for the battery. Okay, let's search for it as voltage. Let's see if we can get ngSpice voltage. Wow, this is it. This is it. This is the voltage for the ngSpice that we can use. It might be, yeah, okay, let's use this independent one or linear voltage. So we are going to use this and escape these, cancel these, and let's delete this. So anytime you are dealing with uh, simulations on Eagle, you need to add all those modules to it. So let's move it. So let's connect this and this. So we are going, okay, now let's try to find the ngSpice for the voltage regulator. Voltage control. So let's check if there is ngSpice for it. So it seems there is no ngSpice for this, for the voltage regulator. So we can escape these and just remove the voltage regulator for now. And remove this. Then try to connect these again. Let me delete these again, and connect them back again. So yeah, we have reduced some of these. We've removed the voltage regulator. Then we can. So we are using we. So let's get a value for this. What's the value of this? It's currently 0 volts. Let's make it 12 volts or 9 volts. So the input voltage is the same thing as the voltage that's coming here from here. So the next thing is let us add this model. Let us add the transistor as a model. Add this model. Can you see here we have done here. So let's map it. Okay. Okay, okay. So these has been mapped. The transistors have been mapped. Oh yeah, points directory. Yes. Okay. So done. Okay, done. So we've mapped all these, we've mapped them together. So the next thing is to add this voltage probe back again. Okay, before adding the voltage probe, we want to rename our voltage. Here we have the VQ here, and here we have V output voltage. So let's move it. So the next thing is to add the voltage probe. We had the voltage probe here is going to give us VQ. We had the voltage probe here is going to give us V out. So V input, VQ, and V out will be of the voltages, or will be the voltage for our simulation. So let's try to simulate it. Wow. So everything is now added. So the next is for us to simulate. Let's simulate it and see the output. We wait for it because we said the start time should be 20 milliseconds and the stop time should be 20.02 milliseconds. So let's wait for it to simulate and display the plots, display the output for us. Wow. So these are the simulations. This is a graph. This is simulation, and this is telling us what is currently happening. For the V inputs, the input voltage here is 12 volts, which is what we can find here. The time it takes for the current to move through the circuit is this, or for the simulations. So here, due to the current, due to the resistor, this is the component we are having here. The voltage here reduces to 11.62. And at the end of the day, it amplifies to 12 volts again, making the voltage output to be what? To be 12 volts again. Um, so this is the signals, or these are the signals, the digital, the analog. So this is the simulations. This, for example, at this time, while simulating, at this time, what happened? The time here, what is the voltage? So the transient currents here, this is the value for it. So this is output of what happened. It has, for each values, for each voltage, this is transient analysis for the voltage. Net list, we don't need this net list. So these outputs, this is what happened, and the plots. This is a plot of the thing that happened, of everything that happened in the circuits. So this is simulations. This is a waveform. We are dealing with a DC, so that's why you can see it here. Let's say it's an AC. The voltage will be a sinusoidal, or it will be a sine wave, but this is a DC. So this is what is known as if I want to save the name for waveform, this is how I can save it. to my system. I name it and save it. But here I'm not saving anything. So close signals. If I want to get the signals, for example, if I want to display the signal for only VQ, apply changes. So this is the signal that happened. This is voltage during at this junction, where we have the output of the first transistor being the input of the second transistor, like this. So this is a way to simulate a circuit, and I will open for questions now. So hope you guys understand what we did here. Let me stop sharing the screen. I'll come back here. Okay. Yeah. So let me stop sharing the screen.